direct variation. So we're still looking at proportional relationships and unit rate, but we're going to look specifically at how the y value changes when you change the x value in a rate or proportion, and it's kind of what we call direct variation. So let's get a good definition or a quick definition for direct variation. And I've got one right here. Direct variation, a relationship between two variables that can be written in the form y equals kx. Hopefully this y equals kx looks familiar. We've used this before. You encountered this in 7th grade when we were talking about proportional relationships. And really, when we talk about direct variation, what we're going to look at is how the y value changes when you change the x value. Which hopefully makes sense, which you do when you change that k. But remember this k right over here, just in case that's a mystery to you, you're not remembering. The k is standing for, really it's your unit rate or your constant value. I'll put that in. The k equals the constant with a c constant, or your unit rate. And you'll see that when we do an example real quick, but I'll jot that in purple just out to the side. That's what the k is going to stand for. That's the value we're going to put in there when we solve for unit rate, and we're trying to change with this direct variation. So let's look at an example. So let's drop down here. Let's look at this word problem. We got a table, a couple methods here, and I don't think this is too bad. I think you'll get the hang of it, but let's try it out. Aaron was paid $63 for 7 hours of work. He wants to know how much he will make if he works 32 hours this week. Aaron used two methods to determine his pay for working 32 hours. Here they are, method 1, method 2. Let's look at the table first. Let's look at the table here, which we've looked at here with proportional relationships and unit rate. The information we're given says, hey, he makes $63 if he works for 7 hours. He wants to know, hey, if I work for 32 hours, how much will I get paid? And there's a couple routes to this, but probably the easiest way is to determine the unit rate. Figure out the unit rate. Sorry, I switched my screen there. The unit rate for how much he gets paid, essentially, for 1 hour of work. All right, so how do we do that? Well, we take the information we're given, this 7 and 63. Basically, if you divide 63 divided by 7, some of you guys can do that in your head mentally, you will get 9. 63 divided by 7 is 9. So Aaron here, for 1 hour of work, if we dial this down, this middle section here, we're going to use for our unit rate value. So for 1 hour of work, Aaron makes $9. So that doesn't solve our full question here, but that does kind of move us on the way. What we can then say is, hey, if Aaron wants to figure out how much he'll make in 32 hours, we can take 32, and we can multiply it by 9, 32 times 9, and we can multiply this thing out. If you multiply 32 times 9, we could do it real quick, or you can put it into the calculator, but you're going to get, do this in purple, you're going to get 288, 288, and that's how much Aaron can make in 32 hours. Make $288, not bad. So the second method is we could do kind of an equation method. So what already happened, what's already set up for you, is the information we have. Aaron was paid $63 for 7 hours. Well, that's kind of the y equals kx version of this. The y equals kx version of this. So the y equals the information we're given. $63 is how much he's paid for or he makes the $7. He works $63 is what he paid for the 7 hours of work. So that's what we're showing in the equation right over there. $63 equals kx, the y right over here. Remember, this is kind of our y information, and this is our x information. So that's where we're getting the 63 and the 7 from. And can we solve from there? Actually, could we work this out and could we solve? I'm going to erase and show you, yeah, we can actually. Kind of like we would solve equations here. That's on the right over here, that's k times 7 equals 63. The opposite of times 7 is just to divide by 7, if we divided both sides by 7. And we get a cancel here, and k would equal 63 divided by 7 is 9, and we get the unit rate. Okay, so we can basically solve for the unit rate that way, and then use it to figure out hours if we wanted to. If we wanted to make, if we wanted to go to 32, we could figure that out, and we could go and solve from there. So what we do in the equation situation is say, hey, I'll draw a line to kind of separate this. Say, hey, if we wanted to solve that in the equation situation, if we know the unit rate, if we know k equals 9, and we want to figure out how much he would make y in 32 hours, instead of 7 hours, we put 32 there, and multiply it times the 9, which we just figured out with the unit rate, and y would equal 288. So just a fast version. But essentially, we're finding the unit rate, gentlemen, find the unit rate for this, and then use that value to figure out anything else we would need to figure out for the word problem. So, looking at this real quick to finish up with the example, what is the unit rate in this situation? Let's fill out. We got, well, the unit rate we have, I'll do this in purple. We got it. Unit rate is 9. We could put the k equals 9 if you want. Or we could just say 9. Basically, he's making $9 an hour. And that's our unit rate. And write an equation to represent the situation. So remember when we write the equation, we kind of did here, but we want to write it in the y equals kx form. So we want to write an equation that represents the whole situation. We don't need to solve this one word problem. Basically, an equation that could be used to solve any values here. So what we would say is that the y value equals k, which is 9, x. And then if we wanted from there, put in our variables and actually use what we have and change our variables up, we could have P for the pay, and we could use H for hours worked. So remember, P is our Y value, and hours worked is our X value. So P could equal, instead of Y, we can use the P value equals 9H, and that's the same as Y equals 9X. We just changed out the variables here using our Y and X. So finally, how much will Aaron make if he works 32 hours? We already solved that, but you'll see some word problems like this. He'd make that $288, so we could put that in real quick. A little bit more neat, I'd say. And we're good to go. So bottom line here, looking at direct variation, how the Y value changes when you change the X value with your unit rate, and then always solving for the unit rate when you have a proportional relationship question, always the easiest route to then figuring out the answer to a word problem, filling out a table, and then later on to graphing this. Awesome job, everyone.